Your interpretation regarding the small appliance branch circuit load calculation is indeed correct. The branch circuit conductors are rated to carry a 20 amp load, but the actual maximum load imposed on them is only 12.5 amps. This difference arises from the requirements outlined in NEC section 220.52a, which stipulates that the load on each small appliance branch circuit should not exceed 1500 volt amps. Let's delve into the details to understand the reasoning behind this. Firstly, according to NEC section 210.11 cone, at least two 20 amp small appliance branch circuits are required for the kitchen and dining areas of a dwelling unit. These circuits serve to supply power to various small appliances typically found in these areas. Secondly, to calculate the capacity of each of these circuits at 120 volts, we use the formula power equals current times voltage. In this case, 20 amps multiplied by 120 volts equals 2400 volt amps. This 2400 volt amps represents the total power that the 20 amp circuit is capable of delivering. Thirdly, NEC section 220.52 introduces a demand factor for these small appliance branch circuits. It requires the load on each circuit to be calculated at 1500 volt amps. This value is not the maximum possible load, but rather a calculated load based on typical usage patterns. Fourthly, to determine the current draw associated with this 1500 volt amp load, we divide the volt amps by the voltage. Thus, 1500 volt amps divided by 120 volts equals 12.5 amps. This 12.5 amps represents the calculated current draw for each small appliance branch circuit based on the NEC requirements. The reason for this apparent discrepancy between the 20 amp circuit rating and the 12.5 amp calculated load lies in the NEC approach to ensuring both safety and practicality in electrical installations. The 20 amp rating of the branch circuit conductors is determined by the maximum current that the conductors can safely carry without overheating and potentially causing a fire. This rating is based on the conductor's insulation type, size, and installation conditions, as specified in NEC Table 310.15b16 and related sections. However, the NEC recognizes that in typical residential use, small appliances do not continuously draw their maximum rated current. Appliances such as toasters, blenders, and coffee makers operate intermittently and for relatively short periods. Therefore, the NEC allows for a demand factor to be applied to the calculation of the load on these circuits. The 1500 volt amp load limit specified in NEC section 220.52 is based on the assumption that the appliances will be used in a typical manner, with some appliances operating simultaneously but not all at their maximum load continuously. This approach avoids oversizing the branch circuit conductors and panel board, which would increase the cost of the electrical installation without providing a significant benefit in terms of safety or functionality. In summary, the 20 amp branch circuit conductors provide a safety margin to accommodate the potential for multiple appliances to be used simultaneously, while the 12.5 amp calculated load reflects the expected average current draw based on typical usage patterns. It is crucial to understand this distinction when designing and installing electrical systems to ensure compliance with the NEC and to provide a safe and reliable power supply for small appliances. The NEC approach to small appliance branch circuit load calculations balances safety, practicality, and cost-effectiveness. By applying demand factors and considering typical usage patterns, the NEC ensures that electrical installations are both safe and efficient. The 20 amp rating of the branch circuit conductors provides a safety margin to accommodate the potential for multiple appliances to be used simultaneously, while the 12.5 amp calculated load reflects the expected average current draw based on typical usage patterns. This approach avoids oversizing the branch circuit conductors and panel board, which would increase the cost of the electrical installation without providing a significant benefit in terms of safety or functionality. It is important to note that the 1500 volt amp load limit specified in NEC section 220.52 is not a maximum load in the sense that exceeding it would necessarily cause a problem. Rather, it is a calculated load that is used for the purpose of determining the size of the branch circuit conductors and panel board. If the actual load on the branch circuit exceeds 1500 volt amps for a sustained period, the circuit breaker or fuse protecting the circuit may trip, but this does not necessarily indicate the violation of the NEC. It simply means that the circuit is being overloaded and needs to be addressed by either reducing the load or adding additional circuits. Furthermore, it is important to consider the ratings of the individual appliances that will be connected to the small appliance branch circuits. Each appliance has a nameplate that indicates its voltage and current requirements. The total load in the branch circuit should not exceed the rating of the circuit breaker or fuse protecting the circuit, nor should it exceed the ampacity of the branch circuit conductors. In addition to the requirements of NEC Section 220.52a, there may be other applicable requirements depending on the specific application. For example, NEC Section 210.8 requires ground fault circuit interrupter protection for receptacles in dwelling unit kitchens that serve countertop surfaces. This requirement is intended to protect against electric shock hazards. It is also important to ensure that the electrical installation is properly grounded and bonded to provide a safe path for fault current to flow back to the source. Grounding and bonding are essential for preventing electric shock and minimizing the risk of fire. In conclusion, understanding the NEC requirements for small appliance branch circuit load calculations is essential for designing and installing safe and reliable electrical systems. The 20 amp rating of the branch circuit conductors provides a safety margin to accommodate the potential for multiple appliances to be used simultaneously, while the 12.5 amp calculated load reflects the expected average current draw based on typical usage patterns. By applying demand factors and considering typical usage patterns, the NEC ensures that electrical installations are both safe and efficient. Always consult the latest edition of the NEC and local electrical codes for specific requirements and guidance. Remember to consult with a qualified electrician for any electrical work to ensure safety and compliance with all applicable codes and regulations. Electrical work can be dangerous, and it is important to take all necessary precautions to avoid electric shock and other hazards. Always de-energize circuits before working on them and use appropriate personal protective equipment. If you are not comfortable working with electricity, it is best to leave it to a qualified professional. Understanding the principles behind electrical calculations and code requirements can help you make informed decisions about your electrical system and ensure that it is safe and reliable. The 2017 NEC is the code version referenced, and it is crucial to consult the relevant sections of that specific edition for precise details. The NEC is updated periodically, so always refer to the latest edition adopted by your jurisdiction. Consider attending electrical training courses and seminars to enhance your knowledge and skills in electrical installations. These courses can provide valuable insights into the NEC and best practices for electrical safety. Stay informed about changes and updates to the NEC and other electrical codes and regulations. This will help you ensure that your electrical work is always in compliance with the latest requirements. Remember that electrical safety is paramount. Always prioritize safety when working with electricity and consult with a qualified electrician if you have any questions or concerns. By following these guidelines, you can ensure that your electrical system is safe, reliable, and in compliance with all applicable codes and regulations. The purpose of the National Electrical Code, or NEC, is to safeguard people and property from hazards arising from the use of electricity. It is important to adhere to all NEC guidelines to prevent electrical fires, shocks, and other electrical-related incidents. Familiarize yourself with the scope and organization of the NEC. The NEC is divided into chapters, articles, and sections, each addressing specific aspects of electrical installations. Understanding the structure of the NEC will help you navigate it more effectively and find the information you need. Pay attention to the definitions provided in the NEC. The NEC includes a glossary of terms that are used throughout the code. Understanding these definitions is essential for interpreting the NEC correctly. Consider the environmental conditions when designing and installing electrical systems. The NEC includes requirements for electrical installations in various environments such as wet locations, hazardous locations, and corrosive environments. Ensure that the electrical equipment and wiring you use are suitable for the intended environment. Pay attention to the markings and labels on electrical equipment. Electrical equipment is typically marked with information such as voltage, current, and wattage ratings. This information is essential for selecting the correct equipment for the application. Follow the manufacturer's instructions for installing and using electrical equipment. The manufacturer's instructions provide important information about the safe and proper installation and use of the equipment. Inspect electrical installations regularly for signs of damage or wear. Damaged or worn electrical equipment and wiring can pose a safety hazard. Replace any damaged or worn components promptly. Use appropriate personal protective equipment when working with electricity. Personal protective equipment, such as gloves, eye protection, and insulated tools, can help protect you from electric shock and other hazards. Follow safe work practices when working with electricity. Safe work practices include de-energizing circuits before working on them, using lockout/tagout procedures, and maintaining a safe distance from energized equipment. Be aware of the potential hazards of electricity. Electricity can be dangerous if not handled properly. Be aware of the potential hazards such as electric shock, arc flash, and electrical fires, and take steps to mitigate these hazards. Get help from a qualified electrician if you are not comfortable working with electricity. If you are not comfortable working with electricity, it is best to leave it to a qualified professional. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with the NEC. Remember, understanding and following the NEC is essential for ensuring the safety of people and property from hazards arising from the use of electricity. By adhering to the NEC guidelines and following safe work practices, you can help prevent electrical fires, shocks, and other electrical-related incidents. The interpretation provided highlights the balance between conductor capacity and the anticipated load demand in residential settings. The NEC acknowledges that simultaneous operation of all appliances at their maximum rated load is unlikely, and therefore allows for demand factors to be applied in load calculations. This prevents oversizing of electrical infrastructure and reduces costs without compromising safety. It's crucial to understand that the 1500 volt amp allowance per small appliance branch circuit is not a restriction on the total number of appliances that can be connected, but rather a factor used for calculating the overall service load for the dwelling. Individual appliances can still draw more than 12.5 amps intermittently, as long as the total load in the circuit doesn't exceed the capacity of the 20 amp breaker for extended periods. Proper circuit breaker selection is essential for safety. The breaker should be sized to protect the conductors from overcurrent, while also allowing for the expected intermittent loads of the appliances. If the breaker trips frequently, it may indicate an overloaded circuit or a faulty appliance. In such cases, it's important to investigate the cause of the overload and take corrective action, such as reducing the load in the circuit or replacing the faulty appliance. The NEC also addresses the placement and type of receptacles on small appliance branch circuits. Receptacles should be located to serve countertop and work surfaces, and they must be tamper-resistant in dwelling units to protect children. Ground fault circuit interrupter protection is required for receptacles serving countertop surfaces in kitchens, as well as other locations where there is a high risk of electric shock. This protection helps to prevent electrocution by quickly interrupting the circuit when a ground fault is detected. The NEC is a comprehensive document, and it's important to consult the specific sections relevant to your project. Understanding the underlying principles and rationale behind the code requirements can help you make informed decisions and ensure that your electrical installations are safe and compliant. Always seek guidance from a qualified electrician when performing electrical work. They can provide expert advice and ensure that your installations meet all applicable codes and regulations. Proper planning and execution are essential for a safe and reliable electrical system. Take the time to understand the requirements and follow best practices to prevent electrical hazards. In addition to small appliance branch circuits, the NEC also covers other types of circuits, such as general lighting circuits, individual appliance circuits, and multi-wire branch circuits. Each type of circuit has its own specific requirements, and it's important to understand these requirements to ensure that the circuits are installed correctly. The NEC also addresses the selection and installation of various electrical equipment, such as panel boards, transformers, and generators. This equipment must be selected and installed in accordance with the NEC requirements to ensure that it operates safely and reliably. The NEC is a living document that is constantly being updated to reflect changes in technology and industry practices. It's important to stay informed about the latest changes to the NEC to ensure that your electrical work is always in compliance. The NEC is developed by the National Fire Protection Association, or NFPA, a non-profit organization that is dedicated to reducing fire and other hazards. The NFPA brings together experts from various fields to develop and update the NEC on a regular basis. The NEC is widely adopted by states and local jurisdictions throughout the United States. It is also used as a model code in other countries. Compliance with the NEC is often required by law, and it's important to understand the requirements and follow them carefully. The NEC is a valuable resource for anyone involved in electrical work. It provides comprehensive guidance on how to install and maintain electrical systems safely and in accordance with best practices. By using the NEC as a guide, you can help prevent electrical fires, shocks, and other electrical-related incidents. The NEC is not a substitute for training and experience. It's important to get proper training and experience before performing electrical work. If you are not comfortable working with electricity, it's best to leave it to a qualified professional. Electrical safety is everyone's responsibility. By understanding the hazards of electricity and following safe work practices, we can all help prevent electrical accidents.